Question 5. Okay, so we've got this nice graph drawn. It's given that f is a 1-1 function defined for all real values. The diagram shows the curve, and these are the values at certain points. State the value of f of 6 and the value of the inverse of 8. Well, yeah, it's a bit different, isn't it? But it's not necessarily a difficult thing to do. F of 6. Well, the first thing to do there is we need to work out what f of 6 is. And f of 6, according to the table, is 14. So this means take the answer from f of 6 and put it into the function f again. The answer to f of 6 was 14. So it means now put 14 into the function and see what you get. And according to the table, if you put 14 into the function, you get 26. And that was all I wanted you to do. The next bit, the inverse of 8. Well, that's the other way around, isn't it? That's like saying, what value do you put in to get an answer of 8? That's what the inverse function means. So we look at the answers this time and find 8, and it shows that you put 4 into the function to get that. So the answer is just 4. And if you want to just justify that to yourself, the reason for that is because f of 4 equals 8. That's where it's coming from. The inverse is the opposite of doing that. F of 4 equals 8. There you go. Right. 2. On the copy of the diagram, remember in your answer booklet there's a copy of the diagram, sketch the curve indicating how the curves are related. Well, I'm just going to do it on this graphic because I've got this ready for me. Remember what happens with this? I think an important first step is we've got to indicate how the graphs are related. So we're going to draw the line y equals x, because that's what it's all about. A function and its inverse we reflect in the line y equals x. So we're going to do a drawing of the line y equals x, something like that, and then draw the graph onto it, reflecting it in that line that we've just drawn. So it's going something like that. That's good enough on the side. And there you've got the graph, its reflection of y equals x. We label it. And if we want to be doubly certain, they did give you a couple of lines to do writing on this as well. We're going to write reflection in y equals x. Just so if there's any doubt in the examiner's mind, they know that you know that that was what you were supposed to do.
Hard for me to do anyway.
There we go. Part 3 then said use Simpson's rule with 6 strips. Now we normally go into one thing of doing Simpson's rule with the little table of values and working them out. The cool thing here is they've worked out all the values for you. It's just a matter of putting them in.
Oh, that's cool.
When I do this, and I know when Steve does this as well, we draw a little table. You don't have to do this time because they're all there. If it helps you, then you could see that your little table that we normally draw with this would look like this, wouldn't it? There's our 7 values, 6 strips, so we must have 7 values, and we're used to putting them into 3 columns. And so we've got 1 and then 8. Remember, you have this pattern: 14, 19, 23 is there, 25 is there, and then 26 down there. And what that means you can then do is go straight to the formula booklet, and it's there for you underneath the trapezium rule. 1/3 of h. H is the difference between any 2 values here, so it's 2. And then it's the first and the last added together. 1 plus 26. And then we've got 4 times the next set of values. So 4 times 8 plus 19 plus 25. And then we've got twice the ones in the final column. And it's just a matter of putting that into the calculator. Have you just done it, Harry?
Yes.
What did you get?
206.
206 looks good. There we go. Alright. And that's there. It's all on the formula sheet. It's all okay for doing that. It might be worth doing the table anyway. If you're used to doing it that way, then just stick with what you're used to, even though you didn't have to work out any values.